Voyager's sending back terrifying information to Earth. The Voyager 1, NASA's farthest-traveled spacecraft, continues to tour across uncovered areas of the cosmos nearly 50 years after its launch. Scientists are baffled by the frightening data that this famous space probe is sending back to Earth. What appears to be a malfunction is being analyzed as we discuss the peculiar records that Voyager has been transmitting back to Earth during its space exploration journey. Scientists have been involved in advanced studies about the universe's past since the Big Bang, which inspired the release of Voyager 1 and Voyager 2, among other space missions. Voyager 2 was actually the first spacecraft to launch, departing from the NASA Kennedy Space Center on August 21, 1977. On September 5 of that same year, Voyager 1 was launched 2 weeks later. Both probes weigh about 720 pounds, similar to a small car. They were released during a window of unique outer planet alignments that caused a slingshot effect to launch the spacecraft from one planet to another. They, however, needed to travel at various speeds and on different trajectories. On December 15, 1977, Voyager 1 was able to bypass its identical twin, and since then, it has been our go-to probe for data about numerous cosmic mysteries. The first spacecraft to accomplish this was Voyager 1 when it began its Jovian imaging project in 1978. It was about 265 million kilometers from Earth and sent a large number of images back to us. Voyager 1 completed an impressive 108-hour stint starting in January 1979, during which it captured 3,750 photographs of Jupiter's rotation, creating a time-lapse film showing the planet's spin. It had passed through the Jovian moon system in February 1979, and a month later, it discovered the faint rings surrounding Jupiter. Voyager 1 also made a unique discovery when it identified new moons named Thebe and Métis. Accurate maneuvers were made to ensure that the spacecraft was prepared for its flyby of Saturn and to prevent a potential collision with Titan, one of Saturn's moons. Voyager 1 also discovered 4 other moons during its orbit around Saturn, including Mimas, Enceladus, Tethys, and Dione. Scientists opted to halt the Voyager planetary mission after the Saturn mission was completed and sent both Voyager 1 and Voyager 2 out of our solar system at a pace of 325 million miles per year. In January 1990, the new mission, officially known as the Voyager Interstellar Mission, began. The most famous images and records depicting the solar system and the planets were taken by Voyager 1 on February 14, 1990, when it was 6 billion kilometers from the Sun. The images, known as the Solar System Family Portrait, included 60 total pictures taken by Voyager 1, bringing the total number of pictures taken by the spacecraft to 670. Although Mercury and Mars were not visible in the images for various reasons, the spacecraft's cameras were shut off to conserve energy and memory before its journey into interstellar space. In addition to the interstellar probes Voyager 1 and Voyager 2, NASA also operates the Pioneer 10, Pioneer 11, and New Horizons spacecraft. Before Voyager 1 passed Pioneer 10 on February 17, 1998, Pioneer 10 was the furthest spacecraft. Voyager 1 continued its journey for another 14 years before it finally arrived in the interstellar environment on August 25, 2012, with no other space probes in sight to catch up with. However, NASA did not publicly announce the accomplishment until 2013. By November 2018, each space probe had officially left the solar system. While Voyager 2 crossed the heliopause and entered the interstellar medium, Voyager 1 is believed to be 14.5 billion miles from Earth. It has continued to provide vital data that no other space probe missions have been able to reveal since it entered the unexplored territory beyond our solar system. The spacecraft has spent most of its 45-year journey in space in good condition. However, recently specialists have identified some abnormal anomalies in its performance. Voyager 1 is currently transmitting enigmatic signals back to Earth, giving the impression that its far-flung state is uncertain. There is a concerning twist to the problem. Although scientists have pre-programmed Voyager to enter safe mode or sound an alarm if it becomes lost in space, it has not done so. Its antenna, which transmits data back to Earth, appears to be in excellent working order, but the data it has recently been transmitting is suspicious. The Interstellar Explorer is functioning, taking commands from Earth and carrying them out, as well as gathering and transmitting scientific data. However, Readouts from the probe's articulation and control system do not accurately reflect what is happening inside, according to NASA officials. Each spacecraft headed for interstellar space, including Voyager 1 and 2, has a special 12-inch diameter gold-plated disc loaded with audio and video messages as a backup in case an alien species discovers the ship. The disc contains 35 Earth sounds, 115 images, 90 minutes of Western music, and greetings from former U.S. President Jimmy Carter and former UN Secretary General Kurt Waldheim, recorded in 55 languages. If it were taken over by aliens, they might attempt to decode the signals. The idea that the spacecraft is currently under the direction of aliens has been quickly dismissed by scientists. Voyager's ability to function depends heavily on its attitude and articulation control system. It constantly keeps its antenna aimed at Earth so scientists can effectively receive data. It also controls how the spacecraft is oriented. Engineers keeping an eye on the situation now believe that the system is working as it should, which only adds to the enigma we already face. Additionally, none of the safety features designed to protect the spacecraft from danger have been activated, according to Susan Dodd, project manager for Voyager 1. A mystery like this is expected at this stage of the Voyager mission. The spacecraft is about 45 years old, which is much older than was envisioned in the mission plan. Dodd acknowledges that the spacecraft's engineering team will face some significant challenges in resolving the issue with Voyager 1. Given the distance between us and the space probe, the challenges are considerable, with the spacecraft being about 14.5 billion miles away from Earth. This vast distance introduces several complications that the team must navigate carefully. A rescue operation is nearly impossible given the current technological and logistical constraints. Voyager 1 is far beyond the reach of any spacecraft or repair project that we could feasibly send. The spacecraft's extraordinary journey has taken it into the outermost regions of our solar system and beyond into interstellar space, where it continues to travel farther from us each day. Messages sent from Earth take nearly 21 hours to reach Voyager 1's current location. Any command or instruction sent by the engineering crew requires a full 42 hours to be received by the spacecraft, including the time it takes for the response to return to Earth. This delay poses a tremendous challenge for real-time problem-solving and troubleshooting. Once Voyager 1 receives a command, any response or information it sends back to Earth will take another 21 hours. This means that two-way communication between Earth and the spacecraft takes an average of 2 days. Such a delay makes it extremely difficult to implement quick fixes or iterative troubleshooting techniques, which are crucial when dealing with complex technical problems. The engineering team must meticulously plan and execute each command, anticipating various eventualities and potential outcomes. Unlike missions closer to Earth where engineers can swiftly send and receive instructions, the lengthy communication delay necessitates a more strategic approach. Each command must be carefully crafted to address known issues without causing additional problems, considering the long time it will take to verify whether the command had the desired effect. The significant communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Each command sent must be effective and precise, leaving little room for errors. This requires thorough testing and validation of commands on Earth before they are transmitted to Voyager 1. In addition to these logistical challenges, the spacecraft itself is over 4 decades old. Launched in 1977, the technology on board, though advanced at the time, is now considered outdated by modern standards. The engineering team must work with systems and structures designed and built in the 1970s, adding another layer of complexity to the problem-solving process. The harsh environment of space also takes a toll on the spacecraft systems. Voyager 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over 45 years. These factors contribute to wear and tear and degradation of its components, making it even more challenging to maintain and repair. Despite these hurdles, the engineering team remains dedicated to resolving the current issues. They are exploring various hypotheses about what might be causing the anomalies and testing potential solutions through simulations on Earth. This careful, methodical approach is crucial given the stakes involved. Any incorrect command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The team is also leveraging the redundancy built into Voyager 1 systems. Like many space missions, Voyager 1 was designed with backup systems to enhance its resilience to failures. The engineering team may switch to these backup systems to restore regular operations if they determine that a specific component is malfunctioning. In summary, while the challenges of diagnosing and solving the issues with Voyager 1 are significant, the engineering team is applying their expertise, experience, and the spacecraft's inherent resilience to address the problems. Their meticulous and patient approach is crucial in handling the lengthy communication delay and the complexities of working with a spacecraft that is both highly remote and considerably aged. Despite the odds, their efforts aim to continue Voyager 1's legacy of exploration and scientific discovery far beyond its original mission parameters. The malfunctions could be the result of cosmic rays altering the spacecraft's delicate electrical systems. These high-energy particles, originating from distant supernovae or other cosmic events, travel through space at nearly the speed of light. When they strike Voyager 1, they can penetrate its exterior and impact internal electronic components. The longer the spacecraft is in space, the greater the probability that cosmic rays will affect its systems over time, leading to sporadic anomalies like those currently observed in Voyager 1's telemetry data. Engineers have long been aware of the potential danger cosmic rays pose to spacecraft electronics as well as human explorers, but the extent of their impact can be difficult to predict or mitigate. Despite these challenges, engineers have employed various techniques to protect spacecraft from cosmic rays, including shielding sensitive electronics, designing redundant systems, and using error-correcting codes in data transmission. Nevertheless, cosmic rays can still pose a danger, especially to spacecraft operating in deep space for extended periods, as in the case of Voyager 1. Although the recent anomalies in Voyager 1's data are puzzling, they are not entirely unexpected given the spacecraft's age and its prolonged exposure to cosmic rays. Engineers and scientists continue to monitor the situation and analyze the data acquired from Voyager 1. They are working to determine the root cause of the anomalies and to develop strategies to mitigate their effects on the spacecraft's operations. Despite these challenges, Voyager 1 has far exceeded its original mission expectations and continues to provide valuable insights into the outer regions of our solar system and beyond. Its achievements are a testament to humanity's enduring curiosity and determination to explore the far reaches of space. As we look to the future, missions like Voyager 1 will continue to inspire and expand our understanding of the cosmos. Voyager 1, the farthest-traveled spacecraft launched by NASA, continues to astound scientists and space enthusiasts alike nearly 50 years after its historic launch. Launched on September 5, 1977, just 2 weeks after its twin Voyager 2, these spacecraft embarked on a journey that has taken them far beyond the boundaries of our solar system into the vast expanse of interstellar space. The Voyager missions were a testament to human ingenuity and exploration, designed to take advantage of a unique alignment of the outer planets that allowed for a grand tour through Jupiter, Saturn, Uranus, and Neptune. The Voyagers provided unprecedented insights into these distant worlds. Voyager 1, in particular, made significant discoveries during its close flybys of Jupiter and Saturn in the late 1970s and early 1980s. One of Voyager 1's remarkable achievements was its exploration of Jupiter's moon system in 1979. Voyager 1 captured breathtaking images and data of Jupiter's 4 largest moons: Io, Europa, Ganymede, and Callisto. These moons revealed diverse landscapes, active volcanoes on Io, icy surfaces on Europa, and a possible subsurface ocean that stirred scientific curiosity about the potential for life beyond Earth. Following its success at Jupiter, Voyager 1 continued its journey toward Saturn. In 1980, the spacecraft approached Saturn's complex ring system and its intriguing moons. Voyager 1's observations provided detailed images of Saturn's rings, revealing intricate structures and interactions between the ring particles. The spacecraft also discovered new moons around Saturn, adding to our understanding of the planet's diverse satellite system. After completing its primary mission objectives at Saturn, Voyager 1 embarked on a new phase of exploration. Its trajectory took it out of the plane of the solar system, heading toward interstellar space. In 1990, Voyager 1 captured the iconic pale blue image where Earth appears as a tiny speck in the vastness of space. This image poignantly illustrates humanity's place in the cosmos and remains a powerful reminder of Voyager's enduring legacy. Despite its age and the challenges posed by the harsh conditions of deep space, Voyager 1 continued to transmit valuable scientific data back to Earth. The spacecraft's instruments provided measurements of cosmic rays, magnetic fields, and plasma waves as it crossed the heliopause, the boundary marking the transition from the solar wind to the interstellar medium. Voyager 1 officially entered interstellar space in 2012, becoming the first human-made object to reach this milestone. The longevity and resilience of Voyager 1 have surpassed all expectations. Originally designed for a 5-year mission, the spacecraft has continued to operate for over 4 decades, far exceeding its planned lifespan. Its nuclear power generators have provided the necessary electrical power to sustain its instruments and communication systems, enabling ongoing scientific investigations in the outer reaches of the solar system. In recent years, Voyager 1 has encountered anomalies in its telemetry data, prompting concerns among mission scientists. These anomalies, believed to be caused by cosmic rays affecting the spacecraft's electronics, have posed challenges for mission operators. Cosmic rays, high-energy particles originating from sources such as supernovae, can penetrate spacecraft and disrupt sensitive electronic components. Over time, prolonged exposure to cosmic rays can lead to sporadic malfunctions and anomalies in spacecraft systems. Engineers and scientists at NASA have implemented various strategies to mitigate the effects of cosmic rays on Voyager 1 and other deep space missions. These strategies include shielding sensitive electronics, employing redundant systems, and developing error-correcting codes for data transmission. Despite these precautions, the unpredictable nature of cosmic rays continues to present challenges for spacecraft operations in deep space. The anomalies observed in Voyager 1's telemetry data have required a meticulous and methodical approach from mission operators. Engineers have conducted extensive diagnostics and simulations to understand the root causes of these anomalies and develop potential solutions. The remote location of Voyager 1, approximately 14.5 billion miles from Earth, adds to the complexity of troubleshooting and resolving issues in real time.